Hello, my name is Jake Laubach, and today I'm going to be talking a little bit about the colon's physiological role in water retention and cholera's effect on the digestive tracts. Alright, so just kind of like a little outline of my presentation, what I'm going to be going through today. First, we're going to talk a little bit about the gross anatomy of the colon, so just kind of like the anatomy on the outsides. The secondary structures of the colon, meaning kind of what cells are in play. The colon's role in water balance, so that's just kind of its physiology and what kind of effect it does have on the body. Then we're going to talk a little bit of how the body reacts to certain water stimuli, so constipation versus diarrhea. And then finally, we're going to go a little bit into a bacterium called Cholera, which can affect our digestive tract. Alright, so this is the gross anatomy of the colon. This image is taken straight from our textbook. And some structures to note here, essentially if this is oriented like if you just stuck it off the screen and just put it right on my stomach. So it's just some structures to note here. The way that food passes through, it starts kind of, this is the point where the small intestine connects to it. And then food will move up the ascending colon to the right colon flexure. Then it will cross the transverse colon, going to the left colon flexure, going down the descending colon, hitting the sigmoid colon, and then eventually hitting the structures like the rectum and then eventually the anus. Alright, so for some secondary structures of the colon, this is just kind of like a cross-section of like one kind of wall of that large intestine, also known as the colon. And it's really important that this kind of tissue has interstitial glands. These holes are essentially so that the large intestine can secrete and absorb different kind of materials. As far as the certain kind of like superstar cells that work here, we have microvilli, which is on the surface of each one of these squamous epithelium cells. And microvilli, essentially what they are is these little hair-like projection structures that greatly increase the surface area. And their main role is to absorb water into the cell. And then we also have goblet cells. Goblet cells, their main function is to secrete mucus into the large intestine, and that's really important because that provides some sort of lubrication for stool and food to pass through. And then we have some smooth muscle fiber here. It's smooth muscle fiber, which means that we don't have control over contracting these things. It would be a lot to have to think about actively digesting something. So that's just something of the parasympathetic nervous system. Alright, so the colon's role in water balance. So the colon plays a pretty big role in our body with just maintaining the water homeostasis. So it takes around 36 to 48 hours to process meals and to have them completely pass through and turn it into feces. There's reabsorption of water and electrolytes during this process. So reabsorption, that kind of word, means that the body is reabsorbing stuff from the food in the stool. It's reabsorbing that and putting it into our body and into our cells. And feces is actually composed of 75% water and only 25% solids. So our body is constantly storing this kind of substance that has a lot of water content to it. So our body kind of falls back on that. If it needs water, it's going to take from it. And this is just kind of like our daily intake and excretion of water. So we get around 1 liter of water from foods, 1.2 liters of water from drinks, which amounts really to 2.5 liters. And for excretion, it makes a lot of sense. Urine is pretty liquid, so that's going to take really the bulk of our excretion of water at 1.5 liters, but still also plays a little bit of a role of factor of excretion of water. Alright, so constipation versus diarrhea. So these two kinds of, I guess they're not diseases, but these two scenarios are the body's response to too much water or a little bit of like something funky going on. So constipation is essentially when your body is dehydrated and it doesn't have too much water, it will take that content of the stool, the water content of the stool, that 75% water, and it'll suck it back up. So it occurs in the large intestine and when it reabsorbs too much water from the stool. And that makes sense because when we're constipated, often our stool is very bulky and it's hard to pass because it's so fibrous. Typically in constipation, fecal matter movement is really slow. Like I said, it's a response to dehydration. And it results from a lack of fiber or even a lack of exercise. So if you're not moving around too much and you're just staying very stagnant, it's harder for things to pass through. Diarrhea occurs for like a big number of reasons. But it's classified when the large intestine absorbs too little water, so that means your stool would be a little bit too watery in your large intestine and when it passes through. This can happen with abnormally high amounts of solute in a stool. So if you have a lot of solute in your stool, our body's going to want to dilute that, and so then we would dump water from our bodies into the stool, which would create that kind of watery consistency. And diarrhea can result from a big number of things. The main ones is like food intolerance, a viral infection, stomach flu, or this last one, bacterial disease, which we're actually going to get into a very specific type here called, oh, not quite. So this is the Bristol stool chart. So essentially this is just kind of showing you the progression of what bulky stool and diarrhea looks like. So in type 1 we have like separated very hard lumps, and this is like the most constipated, most kind of dehydrated your body can be. Type 2 is kind of the same thing, but instead of these clumps are kind of stuck together, so it's like a little bit lumpy shapes. Type 3 is kind of like a smoother surface that still has cracks on it. Type 4 is just completely smooth. Type 5 is just kind of soft blobs, so it's a little bit too much water. Type 6 is kind of fluffy pieces, and then Type 7 is just really too much water content. Okay, so cholera. So cholera, this is what I was talking about earlier about typical bacterial disease. And so the bacterium that's in play here is Vibrio cholerae, and it's a gram-negative bacillus, and it's found in fecal matter. And it can cause diarrhea and dehydration in the body, and this is most common in places of really poor sanitation. Transmission, so this is where you can, like, how you can get that into your body. So cholera can occur when the bacterium Vibrio cholerae is digested in food or water, and possible sources include like contaminated water supplies, vegetables grown with contaminated water, or raw seafood found caught in polluted waters. And this kind of bacterial disease is most common in places of poor sanitation. So say in areas less privileged where they don't have really advanced sewage systems, they're just dumping the raw sewage into like a big stream that people like bathe in, or people eventually kind of like take water to grow vegetables in. That's how this disease can be transmitted. So this slide is taken from a scientific study by A.J. Sylvia. And essentially, it's just explaining the mechanism of what's kind of happening and how this bacterium has that effect of diarrhea in the body. So Vibrio cholerae bacterium can really withstand the acidic environment of the stomach. So like we said, it's transmitted by ingestion, and it goes all the way through your system. It can withstand that stomach and then go to the small intestine and then the large intestine. And essentially what's happening is that the bacterium releases a toxin, and the toxin's made of 3 subunits, A1, A2, and B. So the B subunits really just kind of, the only function of that is to have that bind to the gangliocyte receptor. So this is kind of the intestinal tract, this is the large intestine. So the B toxin binds to that receptor, and then the main star that we're going to focus on today is that A1 subunit. And what A1 does, it increases the amount of adenylyl cyclase activity, which then cascades down to an increased amount of cAMP, and this kind of tricks the body into thinking that it needs to dump water back into the stool. So this increased amount of cAMP releases not only water, water is the big one that we're taking a look at today, but it also releases sodium, chloride, potassium, and chlorate. Yes. So, in conclusion, the colon is the very last structure in the digestive tract. It plays a big role in water retention in the body. Constipation is the response of the body to dehydration, pulling water back into the body from the stool. Cholera, which is a gram-negative bacillus, has a negative effect on the digestive system, and diarrhea is a response to many, many factors. Big thank yous to Loyola Marymount University, Anton, our lab professor Anthony, and Jacqueline Powell. Any questions? Oh, references. Where did they go? Oh, there they are. There are my references. Thank you.